Welcome to this explainer, where we are going to completely break down how to implement production-ready, verifiable retrieval augmented generation architectures. And we're doing it using Java and Spring Boot. Look, if you've been working with Spring Boot and you're thinking, I really want to add some powerful AI capabilities, but I absolutely cannot lose control of my business rules or my data, well, you are in exactly the right place. Let's get right into it. Okay, so let's set the stage by looking at how AI Fabric sits right in the dead center of your architecture. I want you to think of it as the ultimate strict traffic cop standing directly between your Spring Boot application, your vector store, and your large language model. It is not some generic chatbot UI, right? And it certainly doesn't replace your core domain services. Instead, it gives you this beautifully bounded coordination layer. The result? Your application remains in total control of its own truth and its own side effects. Just like mapping out a quick whiteboard session, here is our agenda for today. We'll be hitting 5 key areas. 1. RAG is not one box. 2. Separating retrieval and generation. 3. Bounding the AI context. 4. Generating the grounded answer. And finally, 5. Proving grounding with tests. Starting off with Section 1. RAG is not one box. We really have to start here by shattering a super common misconception about how AI workflows actually operate in a production environment. Comparing monolithic RAG to decoupled AI Fabric shows you exactly why we can't treat this like one magic box. In a monolithic setup, you basically have this unpredictable black box where an LLM is, for some reason, allowed to talk directly to your database. Yikes, right? But in a decoupled architecture like AI Fabric, we draw a hard line. We explicitly separate the rules of safe, predictable evidence retrieval from the raw computational power of the LLM generating the text. I really want to hammer this strict architectural rule home. If you call all of these things together the RAG result, you are completely hiding the exact boundaries that you need to be testing independently. Let's break it down. A retrieved document is factual. It came directly from an indexed source. The context? That is merely a bounded projection of that evidence. And the final answer? Well, that is newly generated wording invented by the model. You've got to keep those mental buckets entirely separate. Moving into Section 2, separating retrieval and generation. What's really fascinating here is how AI Fabric explicitly forces the separation right inside your code. So the absolutely crucial point to understand is that the default RAG service in AI Fabric is retrieval only. Let me say that again. It does not call an LLM. Zero. Its entire job is just to generate a query embedding, search your configured evidence sources, map those results, and build a context string. And the best part? This means you can test it entirely locally, say using ONNX embeddings and a Lucene vector store before you ever even think about involving text generation. Let's map out this progression. First, the AI model merely proposes an intent based on what the user asked. But then, and this is key, your server policy actually validates it. The server then routes it to an allowed vector space, safely retrieves the factual evidence, and finally assembles the context. The LLM doesn't dictate what spaces are allowed to be searched. Your Spring Boot application's policy makes that call. Now, before we even get close to a generated answer, there are 5 distinct readiness conditions that absolutely must be met. Because look, a healthy LLM cannot magically repair an empty search index if your approved source data hasn't finished indexing, or maybe your server policy straight up denies access to the target space. A grounded answer is just simply not possible. And a quick pro tip for your pipelines, please never take the dangerous shortcut of just mashing arbitrary chat history and user attachments into one giant, messy search phrase. The wording you optimize for similarity search has to remain completely distinct from the raw user queries. AI Fabric actually preserves a generation query for the user's request, but it prepares a totally separate, highly optimized retrieval query based on that processed intent. Section 3. Bounding the AI context. So once we've successfully retrieved our evidence, we have to carefully curate and bound it before we blindly hand it over to the model. You really have to notice the strict difference between the total retrieved documents and the bounded context limit. The number of documents you might expose to a user client for them to inspect, like say in a sidebar showing the sources, that is a separate, much larger budget than the strict, highest ranked subset you actually allow into the LLM's prompt context. Why be so strict? Because more context is not automatically better context. Shoving irrelevant or excessive content into the prompt will dilute the evidence and actually make the model's behavior totally erratic. So AI Fabric explicitly truncates the assembled payload at a hard, configured character boundary. This guarantees your prompt remains laser-focused and, most importantly, testable. Plus, we absolutely must label different types of evidence before combining them into this bounded context. Think about it. A retrieved policy document explains the rules, sure, but trusted current facts, like a live read action checking if a user actually has a valid payment method on file, those authorize and execute changes. We never want to flatten these together. An LLM does not own a repository right, and a static policy document shouldn't override a live account status. Moving to Section 4, generating the grounded answer. Now we finally cross the boundary and hand our bounded, perfectly labeled context payload off for actual generation. To pull this off, AI Fabric's AI Core service uses a managed prompt overlay. This strongly instructs the model to act responsibly with the very specific evidence it's just been handed. It forcefully dictates that the model must answer using only the relevant context. It absolutely must not invent absent live facts, and it's required to keep internal metadata hidden from the end user. You've got to remember this golden rule. Returning 0 documents is a perfectly valid, highly successful search outcome if the information simply isn't in your database. The model has to be completely transparent about missing evidence, rather than trying to infer unsupported conclusions just to sound helpful. Remember, a polished, beautifully written paragraph by an LLM is not evidence. Section 5, Proving Grounding with Tests. Listen, if you can't prove it, you can't ship it. Let's look at exactly how we independently verify this entire architecture. You are definitely going to want to screenshot this matrix. It flawlessly structures how we distinguish between different failure states. Think about it. A successful search with 0 matches is fundamentally different from a retrieval provider outage, and both of those are entirely different from a generation failure where the LLM just times out after the evidence was already retrieved. AI Fabric handles all of these as distinct, trackable states. Please, do not add some canned answer that makes a provider failure look like a grounded success. This split approach totally defines our testing philosophy. We test retrieval completely independently, asserting stable IDs and scope enforcement without ever waking up an LLM. And then we separately test generation by feeding the LLM highly controlled contexts just to see if it hallucinates. By doing this, we systematically prove that our Spring Boot application remains in absolute, total control. Which brings us to our final check. I want you to look at your current AI implementations. Can you cleanly answer these 4 questions right now? What was actually searched? What specific evidence was retrieved? What exact context reached the model? And what did the model independently generate? If you can't cleanly separate those answers, are you really building verifiable, production-ready AI? Or are you just relying on magic? Something to think about as you build out your next workflow. Thanks for joining me on this explainer, and I'll catch you in the next one.